All right. We should get back at it. So we left off somewhere around our um, we sorry, we we made sure that we get a how to get the static instance of our sorry, I'm really tired. We made a singleton pattern of sorts for our debug class. We now need to actually create some methods to instantiate our um, um, actual debug component, or rather um, use the actual API interface and we will be calling the function. As you can see here from the example, we have to get the debug interface and store it inside our object, and then we can enable the debug layer from that component. So let's do a function called something like maybe what's let's get interface. Maybe we actually want that to be private, since we might just be calling something like an a void enable function, and we would like a private function to get interface. So first off, we start out by getting our interface, and we could make sure that if we already got a pointer, we won't do anything. So if the comp pointer already has an internal component, we won't be doing anything. Let's see. Everything still compiles. Maybe it's just IntelliSense that's still messing up for some reason. Yeah. So we would like to use our helper macro, since I think that, yeah, it returns an H result. So we can evaluate this function call. And the function call was get debug interface. And we will use the IID ppv args macro. And since it's a pointer to a pointer, we can always get the pointer to our actual com pointer by calling get address of. And this should be fine. Let's see. Yeah, I think we might need a lib for that as well. Let me see. Let me see. The actual debug stuff. Yeah, for some reason the comp pointer stuff is just going nuts. But yeah, do I have to? Yeah, I have to include the .lib here. Let's see. Let's see. Yeah. We would also need that for everything else to work. So now we can get the interface, and we can call that function before we get make a call to get our underlying pointer. Let's see. Since IntelliSense is really messing this up, I just wanted to make sure that I typed in everything correctly. So now we should be able to call get interface, which in return would enable the debug layer. Or rather, when we call enable on this static instance, we should first make sure that we have an actual interface created, and from that interface, once it's created, we call the enable debug layer and set a flag that we have enabled the debug layer. I'm unsure whether we're going to use it, but memory-wise and implementation-wise, it probably won't matter too much right now. So, let's see. Now we should be able to create this component. Let's see. Oh, actually, this is for the debugging of the let's see, for the actual DirectX components. I forgot that there's two different versions, one for the DirectX components and one for the DXGI components. So we actually have to do separate components for that, since sometimes we would like to instantiate and use a debugger for the actual DirectX, and sometimes we want to be able to see, for instance, how many live objects we have in our DXGI uh, uh, part of the application. So we will do another of these classes. Actually, they will be highly similar. Yeah, I have an outline of what to do on uh, a list in another part of the screen. So yeah, I was just browsing through that and realized that I actually forgot that we would like another component. Yeah. Let's see. Yeah. So we'll just do that. We will also create a DXGIDebug class. And move it. For once, I'm gonna remember to declare the namespace first. And as I've said, this code will be highly similar. So we could just somewhat copy it. Let's see. And instead of using that component, let me just have a look. No, not there. Let me see. DXGIDebug. Yeah, so as you can see, the this part of the debugging interface allows us to get information about what objects are living inside our program and what needs to be sort of released or reset before we close the program. You could argue whether you actually remove a component before the or rather close an interface before you close your program is somewhat not really that important, but we would like to handle lifetime cycles somewhat proper. So yeah, since it would be a way of debugging whether our reference counts get too high or rather whether we destroy an object in some part of the code, and yeah, it's just really that much easier to know which objects are live when you have run through the program. So yeah, this function call is really useful for debugging alongside the other debugging information. So yeah, let's see, does it need a library? No, it doesn't need a .lib file. Next, we will be implementing the debug DXGIDebug component the same way as the DirectX12 one. So yeah, let's just create the functions, and I don't really like it to be typed out that way, but you can do whatever you would like. Let's see. Let's put the static stuff first. So let's see. Is that the right way to declare it? Let's see. Return that one. Let's see how many errors we get. since we just copied the code. Yeah, okay. DXGI. There we go. It's supposed to return another type of object. Yeah, should be fine. So let's see. We will do the same thing. If we already, if we don't already have a pointer inside our com pointer to an actual interface, we will be calling this function. As you know, there's not an example, but anyway, and let's use our helper function to create an error message if need be. So yeah, and the macro as always, and the call to the com pointer object. Oh, I'm missing D here. Yeah, it really messes up the coding when IntelliSense doesn't recognize yeah, the different methods and definitions of actual objects. So, or rather declarations. But yeah. Bup, bup. So if we, for convenience, would like a wrapper for the function call, here we could write that. So as you can see, this function call reports about the lifetime of an object or objects. There's an example. And I'm unsure whether there's an actual overload of this one. Oh yeah. Oh, let's see. Yeah. So we specify a a new sorry, unique identifier of um, uh, the objects we would like to get information about. As you can see in this documentation, we're able to pass in the DXGIDebug all. So we get all Direct3D and DXGI objects and private applications. We would really like that. So yeah, since we don't want the hassle of making explicit calls to that function, or rather pass in all the arguments each time, we would like um, a public method that just passes in the arguments for us. We could also do variations of those if we wanted to, but yeah, I would like to just get all the information whenever needed, since usually when we call this function, we will be wanting debug information. So let's see. We could call it get live objects of sorts, as long as it makes sense what we're doing. And we simply get the goddamn IntelliSense. So yeah, this is our internal pointer of the com pointer. We call the method report live objects, and since IntelliSense is really screwing about, I have to copy our arguments manually from the documentation to be sure that I'm not misspelling anything. So yeah, the first parameter is the globally unique identifier, and as I mentioned before, we will be using the debug all. Yeah, you could selectively, as you can see, differentiate if you wanted some other specific information. I haven't really found the use for it, uh, but you might know something that I don't. Yeah, and then we need to specify some flags. Uh, and let's see, we would like to get a summary, perhaps, or rather maybe the details. Uh, yeah, let's see, what would we like to get information about? Maybe we just want it all. Let's see. Uh, Maybe we don't want the internal information, because yeah, when we have no external ref counts keeping objects alive, uh, we don't really need to get information about them. Uh, um, yeah, so as you can see, the flag means that we ignore objects which don't have an external ref count, because our application is not responsible for keeping them alive. I think a combination of uh, the details and that we ignore the internal ones. Yeah. So this is a bitset flag specifier. So the way you combine flags are by specifying each flag with um, a bitwise OR operator in between. Um, this combines the flags and makes sure that they both are used. Just to be explicit about the type, we cast this as a flag. Yeah. So now we should get information about the live objects. Let's see. Linger error. Let's see. Did I forget to include something? Yeah, maybe I didn't include the DXGI. Oh, I did. Maybe. Let's see. Oh, I'm not sure what the lib is actually called. Since we get a linker error, we of course have to link up to something like a DLL or .lib file. So yeah, I'll just Google it. It's way faster. Pragma common lib. DXGI debug lib. Let's see. I actually have some old code where I did it, so I'm just gonna look it up. Let's see. I did include the header here, right? Yeah, it's right here. Debugging. In case we eventually want to split our application into a distribution build and a debug build. I'm just going to specify whatever we use. Let's see. I'm just going to look up the old project here. Yeah. So, I think it might be this .lib file. Yeah. So we have the DXGI, we have the DirectX12. I think we need to include the GUID because the linker says it can't find the DXGIDebug all flag, or rather globally unique identifier. So yeah, I think we need to include that one. Yeah, one of them went away. Let's see what's the next one. Okay, I'm messing a bit around. Perhaps let's see. How do we link up against this one? Let's see. Perhaps we can find a lib version of this one. to use any of the should be working, I think. Get interface. That is a bit annoying. Maybe I would want let's see, I'm just gonna check out hmm. And let's see if I look up the method call and let's see DXGILib. He got it working. Let's see. Maybe let's see. Maybe I'm just calling the wrong version of yeah, I think so. Let's just look up this version. Let's see. Up. Flags not used. Brilliant. That is somewhat nonsensical. All right, there we go. So now we can instantiate a singleton of the DXGI debugging and DirectX debugging. Let's see. I think I need to. Let's see. Yeah, we evaluate that result. We need to perhaps. I think we need to call the. Let's see. Is there an example in this one? No. What methods do we have in this interface? Report live objects. Is that it? Has these methods. One method listed. Oh man, documentation at its best. Yeah. So whenever we actually call the get live objects, we want to make sure that we actually have an interface. And since it won't repeat itself once the pointer gets set, we just make sure that the interface is valid. I'm not sure I want to have a flag that tells us whether this one is running, since you will just use it to get a dump of the live objects. So let's test it out. In our renderer, we will include our debug. Let's first get this one. So during this scope, we instantiate our DXGI factory, which is a compointer to a DXGI factory 2. And our constructor specifies that we actually create a DXGI factory and store it in our compointer, which means the reference count should be 1. So if we include our DXGI debugger, we should be able to oh, something went wrong. I haven't made the proper definitions, I guess. Public static DXGI debug get. Maybe maybe I want to maybe it's just because the IntelliSense is not working properly. It really makes it so much harder to be sure that you write any code that makes any sense. Hopefully it will resolve itself eventually, but yeah, let's just do a function call. Yeah, as you can see, I get really uncertain that I'm doing things correctly. For now, I'm going to close these since we don't need them. We want to call this method. It is public, so everything should be working fine. Since when we call the get function, which is static and public, we should be getting our instance. Yeah, so this should work. And it somewhat does. Let's see. Get.pointer is a null pointer. So somewhere we have an error. Let's just step through it. And if we step into this, let's see. Unable to read memory. That isn't great. Huh? That isn't great. For some reason, we don't get let's see. Let's see. It should really be working. Something is happening when we call the what's its name? the get interface. Let's see. Did I structure the pointer itself wrong? That is somewhat weird. Let's just walk through the steps. So we step into this method. So far our pointer is null. It returned null, so it steps into this function. Huh? What if I... So something is wrong with... Ah! We found the error, right? Yeah, I think we found the bug. Somehow it still compiles. Maybe... Yeah, I'm pretty sure this is the bug. Yeah, as you can see now, we get an actual address for our pointer. Yeah. Stupid mistake. Sometimes it happens though. Alright. Now we can see what this function actually does for our application. So now we close it. And as you can see, we get a new output. Actually, this single line is our method call to this function. We get a report on every live object. Currently, when the function gets called, we have a live IDXGI factory at a specific memory location, which has the ref count of 2. So that is basically the output. If we created several other instances of objects that we want to monitor the lifetime of, they will get listed here. Just note that sometimes you miss that there is something in the output. So yeah, I tend to do a habit of just dumping the live objects after a program gets terminated. Then I can see how I manage lifetimes during the application life cycle, and I usually don't pay much attention to this information dump unless I try to do some debugging, or something isn't really running as intended, or if I have objects that have odd behaviors, perhaps I reuse a component somewhere unintentionally or something like that. So yeah, and since this is more like a status of the whole program and the object life cycles, it makes sense that you only look when you are uncertain whether something bad is happening. But that is specific for this DXGIDebug object, which handles the DXGI application layer, as we saw earlier. The the DXGI um, the DXGI infrastructure, or rather the DirectX graphics infrastructure, is a specific part of the application layer. Layers, of course. Yeah, so there's a huge difference between this component which we've done and this component. Although they are somewhat the same in syntax, this is a component that usually reports sometimes live during the application runtime, and allows you to see whether you, for instance, made a mistake during buffer instantiation and so forth. Buffers are something we will get to eventually, but buffers are like any other buffer in programming, just a memory allocation with a certain alignment and size. So yeah, but yeah, for instance, that could be a thing that you would see live during your uh, application runtime, and it would get dumped here. Usually, when we do applications that aren't very complex, they the error messages or problems gets dumped for every frame. So you would have to really not pay attention to your output if you were to miss that something is wrong. Of course, if it's during the application or render initialization, you might miss it, but usually, yeah, it would be hard to notice miss. Yeah, so they are really different, even though they are somewhat similar in syntax, and yeah, bear that in mind. They both use the output of the IDE. Yeah, so now we have created our two singleton patterns, which will help us debug. As I've mentioned earlier, perhaps you want to split the build into a distribution and a debug build. So be wary that right now we just do one build, since there's nothing really to distribute. Yeah, all right. So far, so good. We really got a lot done today. So far, let's see. I've kind of laid an outline that was the debug layer. For DXGI and DirectX12. We've done some macros, helpers for now, and we got done in the last episode with our factory. Now we want to move on to what is called an adapter and a device. And eventually we want to link it up to a so-called swap chain. So that is the roadmap for the series going forward. As I've said during the first parts of this sort of live stream, course, whatever tutorial, I've prioritized getting something passed onto the screen, since that is way more fun. We can always do the refactoring and restructuring of our code eventually. So yeah, but when it's somewhat faster just to create a component for our system, I'll do that. Although there might be way faster implementations. But yeah, since we're in for the long haul, it's you know, weighing of what would be easier to do now, um, versus what would be easier to do down the road. All right. So far, so good. So we should look into creating a um, an adapter. Um, I'm actually unsure whether I usually do the adapter or the device first. Sorry, my headset is bugging out. Sometimes it just shuts down without any notice. I'll try to fix it. Yeah, so an adapter. Let's start by looking up the adapter. Whoops. Um, the adapter um, component of the DXGI. Let's see, maybe, yeah, there it is. So the DXGIAdapter interface represents a display subsystem, including one or more GPU, DACs, and video memory. So we want to create one of these, since we definitely will be using a GPU. And welcome to all the Twitch viewers. I hope everything is enjoyable. This is my first time streaming on Twitch. Yeah. If you haven't watched any of my previous content, I'm primarily on YouTube, and I am not a professional programmer. I'm a hobbyist, but I've done a renderer in DirectX12, which is able to load different models and so forth before. So I've decided that I want to do a video game from scratch, and since I really don't like editing, video editing, since I suck at it, I decided that I'll just go ahead and stream the whole process. This means that you will see me messing around with code and yeah, IntelliSense and so forth. Yeah. Anyway, uh, we should get going. Let's see. We want to create a new class called DXGIAdapter, and the pattern is gonna be like the previous components. We will put them in our namespace, and we will be inheriting from our Microsoft compiler. And let's see, I always have to look up what version of the actual adapter we want. The problem with DirectX12 and DXGI is that they regularly update the interfaces, and therefore you have to find out which version you want to call, and thereby which interface you want to use. So let's see. Does this one have any specific? Yeah, it has a 1. Let's see. What's the difference in inheritance? So we could get the description. Actually, that could be useful. Let's see. DXGI 1.0 versus the DXGI 1.1. Get description 1. Let's see. Description 1. So we would get a vendor something about the actual memory. I'm just going to copy it here for comparison. Perhaps, nah. I'm gonna just create a new window and compare them like that. There we go. So, what do we get out of flags? That's the only difference. Okay. Let's see. Yeah. And the flags are what? Let's see. The flags. Adapter flags. Oh, okay. So it's for some kind of other way to use adapters. I'm pretty sure we don't need to use the flags in our implementation, so you could just use the adapter one if you wanted to, but let's see. I'm pretty sure it's not needed. Yeah, so now we want to create an adapter. Let's see. I actually need to look up the keyword here. No except. Yeah, I think. Yeah, we don't want to throw exceptions if we create an empty DXGIAdapter. So we will create one during construction that is empty without throwing any exceptions. Yeah. An adapter needs to be able to specify a monitor, a let's see. Yeah, a monitor which is connected to the output of the adapter. So in the future we would like to be able to find the monitor for this component. We also want to be able to pass in another adapter and use that inside our object here. So let's create that constructor, and as per usual I'm gonna move the namespace here. And since this constructor is supposed to just create a compiler with the specific adapter, we do it like that. For now, we won't be dealing with, let's see. Let's see. I did something wrong somewhere. It's because I couldn't type properly. This should be fine. No? Not yet. Well. Yeah, there we go. So yeah, for now we're not going to implement the actual way to get a monitor, because we need some uh, structures to handle that information. But yeah, basically these are just wrappers for our COM pointers with extra functionality that we can implement. It is very much like the way the actual um, um, implementation of the DirectX and DXGI API is created. As you can see, we have objects that inherit from an unknown interface, which is a general interface, which allows us to query for the interface or add references and release the interfaces and so forth. Yeah, so we're basically just extending the API and creating structures that we have more control over, and which or rather not control, but which suits our needs. All right, so that is basically the first part of the adapter. So we still need to do something about a way to get the monitor. Let's move on to the device. We will also be creating a device. Let's see. I actually think it's part of is it a part of the no. So we have the basic hardware level. Let's see. If we do paint, we have the basic hardware level. Oh, that isn't very nice, is it? We have the DX, whoops, GI layer, and which handles our hardware. And we have the DXGIAdapter layer, which are um, interfaces on that hardware. So let's call it interface. I shouldn't spell it out. And of course, these two layers, uh, the DirectX12 layer needs the DXGI layer to do anything, since it kind of refers back into the components that the DXGI handles. Yeah, but we will start moving into the DirectX12 space, which means we will also make a new folder structure here that we need to call something. So if we have our debugging systems, we have our DXGI systems. We could perhaps call it something in regards to the actual output. Perhaps we want to define our devices and our swap chains inside the same folders. Let's just call it output for now. I think I might change the naming eventually. So yeah, as per usual, we will do the D3D12 device. And as you can see, the naming changes. So it's still preceded by an I for interface, and then we start to go into the DirectX12 specific API. So this represents a virtual adapter. So the DXGI represents a hardware level adapter, and it's used to create a lot of different things that we will have to implement and handle eventually. But yeah, it is an essential component. So many different components of DirectX 12 need a virtual device, or rather a virtual adapter, to do anything. As you can see, we have several methods. Like, this list is pretty long compared to whatever methods the DXGI components have. So yeah, sometimes we want to be able to call some of these methods with specific arguments without having to pass in uh, the arguments themselves every time. So we will of course be creating a class that can do the basic API interactions. So we will be creating a D12 device, maybe if you want to implement a DirectX11 device, you could do that. Therefore, I'm just gonna make it obvious which one we're using. So we're gonna use the namespace that IntelliSense really doesn't like, and which I've been struggling with forever. It really feels like. Let's see. So right now, as you can see, IntelliSense does recognize that we have different versions. Maybe we should look into what these different versions enable. But for now, we're just gonna create a basic device. Let's see. So yeah, a a DirectX 12 device 10 is to be displayed in the documentation. It seems like Microsoft hasn't been paying attention to the documentation for a while. Oh well. It is related to the Agility SDK. It has several interesting features, but we certainly do not need those for now. Let's see, create committed resources. Yeah. It's probably just different implementations of these function calls. All right, so we could use pipeline state stream descriptions. If we chose to use a device 2, we could special purpose diagnostic heaps. All right, interesting. And these extend the interface without specifying what they actually extend. Shader caches. I'm kinda leaning towards using the 9 version. I'll check what I used to do the last time I created a device. Let's see. I actually just went with the base device. Shader cache. Behavior of caches. Only in developer mode. Alright, I don't think we actually need the functionality of that. A unique creator ID for the command queue. Yeah, we can always return to this part of the documentation if we want some specific functionality. For now, we're just gonna use the base device. We definitely won't be using the Agility SDK because that requires further setup, and I haven't really tried out the SDK yet. We're doing this without any libraries, so yeah, we should not need that functionality for now. All right, a lot of deliberation on nothing, as you might say, but yeah, I like these videos to show that you can look up in the documentation and find out whatever all these different implementations and different structures really do and what difference in functionality they have. So yeah, and since I don't really know all of the functionality of the DirectX 12 library, we might as well just look it up every time. Yeah, so but I would like the application to be able to create an empty um, device, so we will create a default constructor. I think this should be public. Did I forget to make it public? Yeah, I forgot to make it public in this one as well. I just remembered. Okay, let's see. We can close this for now. We don't need the debugging layers. All right. Let's see. The device has a method that is called, let's see, a create device to create the virtual adapter. And to call it, we need an adapter. We need a minimum feature level, and of course we have to pass in the unique identifier for the interface, which is our actual object, since it inherits from the COM pointer, and of course the memory block with a pointer to the actual device. But yeah, so we need to pass in a adapter and decide on the minimum feature level. So now we're going to start doing that. Sorry, I just got distracted. Yeah, so that means that besides being able to create a device that is empty, we would also like to be able to create a device by passing in an adapter, and of course we could do extra functionality. For now we don't need that. We are just gonna create the constructor, as per usual, and we could do some error checking. Just a second, I might have a dog that wants to get in. All right. All right. He got settled. So yeah. As mentioned, we need a feature level and the adapter to call the create device function. To use our helper for that function, we will copy it in. Yeah, I won't be doing a lot of typing since the IntelliSense is really missing with me. Yeah, but we will evaluate this result. We will be specifying a feature level of sorts. I think this is an enum, yeah. So we can actually look inside. There are different feature levels, which we will return to eventually. So this has to take in an adapter, which is our pointer. We could check whether this is a null pointer, but usually this gets called after this is constructed, and if it's a null pointer, we would catch it somewhere earlier and throw an exception. So it shouldn't be necessary to do error checking. If you want to be certain, of course you can, but so it's a minimum feature level. But for now we pass in this and use our macro to make it gets stored in our com pointer. So now we have to set the minimum feature level, but first let's look up what it actually means. So as you can see, it's an enum, and there's a specification of what the enum covers, and there's a history of different feature levels. Let's see, if we look them up on Wikipedia, we can actually get something that makes more sense, because this is somewhat a short summary, but shader models are something that we will get back to. Shader models are basically what you are able to do on your GPU. Your GPU has different shaders, and for instance, there's a standard input shader which handles specific basic data, but we also have mesh shaders that are able to expand on basic data using different algorithms, and you have tensor shaders that are used, for instance, in ray tracing and so forth. So as you can see, the different feature levels are laid out, and is actually coupled in this table to a GPU. So if you have an older GPU, you might have to use a lower feature level. You might see that even AMD GPUs are rather, I don't know why I said that. Of course, AMD GPUs are referenced here. I just, yeah, sorry, that's a brain fart. DirectX12 is, of course, manufacturer independent. It's just an API. So, yeah. But we get something like tiled resources tier 2, which you might not know what is. And typed UAV loads and so forth. We have conservative rasterization, blah blah blah. Yeah, so we have a lot of nice features. Oh, I'm actually looking at an older table for DirectX 10 and 11, but they are basically the same. So as you can see, DirectX 12 with a feature level of 12 allows you to do resource binding and use the shader model 6.0. As far as I recall, shader models 6.0 allow you to do indexed data structures inside the shader language. Let's see. Yeah, I'm unsure whether it's 11 or whether it's 12. Anyway, 12.2 has the support for DirectX12 Ultimate, which has upgraded versions of ray tracing, mesh shaders, and different ways of binding resources. As you can see, you can have a three-dimensional texture, also called a tensor in different areas of computer science. It's basically, if you have a matrix with 2 dimensions, it's just an extra dimension, and so the data is structured 3-dimensionally. You could imagine like slices of data which are two dimensions stacked upon each other. Anyway, I think we might just run with a feature level that should include most modern GPUs, and therefore yeah, I think I want to use a feature level of 12. Nah, let's just make sure that if anyone watches this, that we don't exclude any types of hardware. Let's see, maybe we just want to pass in the actual feature level. Is it able to recognize that one? Yeah. So maybe we just do, oops, do like that instead, hard coded inside. You could do something like checking for whatever feature level is supported at the minimum. So we could do checking for minimum feature level. We could do it by creating a temporary device with an absolute minimum feature level, and we could compare that device method call to let's see, create device. We're not gonna change that device, so we could call get feature. That's not what it's called. Feature level. Let's see. Sorry for the noises. Let's see. maybe it was a newer version of maybe. Oh, anyway, there's a method call somewhere that allows you to get the feature level of the device that we just created. Um, feature level with an array of supported feature levels. So that just means that we can throw an error if we don't find that the GPU doesn't support the wanted feature level. For instance, if you found it absolutely necessary that you could use the uh, specific tensor cores or the AMD equivalents on the hardware, you would have to make sure that you don't create a device with a too low feature level. Yeah, so um, yeah, so you could do that. You could use the, let's see, check feature support function, or rather method for checking whether um, the um, whether the features are supported, of course. Yeah, but yeah, we're not going to do that. If you have different hardware, you should know where to look up the specific feature levels required. Um, we might change this in the future. Let's see. We still end of macro. Maybe I forgot a parentheses somewhere. Did I? Yeah. All right. So now we create a device. Um, and that's basically it. You could do it more complicated, but now for now we just do simple features. You could ask why not just create each object as a COM pointer or store them in the renderer without creating the wrappers. But yeah, since I know that eventually you want to do error checking um, and feature level checking and several perhaps other features for the actual device, yeah, I started out by creating the wrapper. All right, so far so good. We have started creating our factory, the adapter, the device, and we're getting in reach of the actual swap chain. The swap chain is a lot more complicated to implement than any of these features, and I will surely be uh, having a break uh, before I do the swap chain. Um, yeah, since um, yeah, since it's somewhat elaborate, and I try to separate the streams a bit, since each episode that gets stored on YouTube might get really long. So far, we have been going for 1 hour and 40 minutes. So, yeah, I have to break it up in somewhat manageable parts. Um, all right. But before we end this episode, we should do a bit of testing. So let's say we want to test out some of our stuff. We already included the factory. I'm just gonna move this so that it's easier to read what is used for what. And we will be using our DirectX layer for this, since we started creating components that are not DXGI related. So let's see. We want to, no, there's not any further DXGI components for now. Let's see. Oh, I didn't move him into the output folder. There we go. All right. And dear IntelliSense, I want you to help me out. So let's say we enable our DirectX 12 debugging layer. We want to do that beforehand. We want to report our live objects. Let's see. So to create the different parts we need to use the parts we created. Since we specified that the DXGI adapter is able to take in another adapter, we can create one of those by simply doing a copy assign. As you might see, the methods aren't disabled. So let's see. The factory is used to create a swap chain, create an adapter, and several other things. We haven't really implemented a get adapter function on our wrapper for the actual for the factory. Yeah. So we would like to um, um, let's see. We would like to create the actual adapter on the factory. For now, we will create a method for that. It's not supposed to return a void, but for now, while we implement the method, um, we will not be returning anything. Uh, I eventually it will. Perhaps we should just do it. Eventually, we will be returning an adapter. So maybe we should just return it straight away. Right now, we return an incomplete type. Let's see. Let's see. Um, it can't find the empty constructor. Didn't I implement it? Let's see. Yeah, that is the problem. All right. Yeah. All right. So we want the factory to kind of find out whether we can find an actual adapter. So remember the DXGI is on the hardware level. Um, so we want to um, kind of query the uh, query the query the factory for what it's able to uh, create. We won't be using a software adapter. Uh, we want to uh, use this function, which enumerates the number of adapters of um, 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 I'm sorry, I'm really tired. Um, so we want to use this method to get the actual adapter from the hardware that is available. So we um, we yeah we create a factory and kind of like query for what adapters are available. This method enumerates the adapters and to, as you can see here, um, to change adapters, we have to recreate the factory, and it's dependent on the amount of display cards. Um, yeah, so we can get a reference to our actual hardware and store it into a structure. Uh, it returns the adapter with the output on which the primary display is shown, which corresponds to an index of 0. Yeah. So as you can see, we can create a vector of different adapters as long as we find one. And that's one way of doing it. Let's see, we would like to see if there are different versions on how to do it. Yeah, so there are different factories. So for example, factory 6 enables a uh, um, method that enumerates graphic adapters based on a given GPU preference. We don't need the notifications for state changes, but perhaps it would be interesting to be able to get a specific GPU. These days it's not entirely impossible to have several GPUs. For instance, maybe you have an on a separate chip, or rather GPU on your actual CPU, or you might have several video cards. So um, we might find that um, we would like to query our hardware for a GPU with the highest performance. So yeah, we have a factory which is initialized once we actually create it. We want this function to return an adapter. Since our factory is created in regards to allowing debug mode on the application, we don't need to change the type, or rather version of the actual object. We can just create a new factory of the type. Let's see, DXGI factory, and it was version 6, temp factory. And when we call the method, we can actually sort of recast our current factory as a different type. So if we do the query interface DirectX method, so we can use it to get a weak reference which isn't reference counted and which is somewhat temporary to an interface. Uh, um, so we can basically check if an object supports an interface by using the query interface. Or rather, I messed up. Yeah, the text here says that we can query whether we're allowed to use a specific interface of an object, um, and that would increase the reference count. So we can do a funny little interaction between the compiler uh, methods and our query interface from the DirectX API, and we can do a uh, um, no, I don't want the result of it. I want to test if the current factory, which is related to our object, is able to use the interface of type factory 6. Um, and yeah, we're in that situation where IntelliSense really isn't helping us. So let's say this succeeds. I'm gonna test it out since IntelliSense is really messing with me. So if we call the method, not even that, does IntelliSense really register? Should be like that. Okay, I misspelled something. PPV args. Let's see. Double underscore. There we go. Yeah, so everything works as intended. Um, so now we could use our helper macro to say, yeah, well, this succeeded. Success. And we don't succeed. Which is let's see. I think I know why. It's because if we look at the documentation, the query interface um, it returns the value back from the interface. Let's see. We're allowed to query the interface. Yeah, the IntelliSense really doesn't know what we're doing here. I'm I'm pretty sure that yeah, okay, it's because we're inside the no, we need to get the DXGI, the the factory. Does it have? It should actually. Is it because the DXGI object unknown query interface? Let's see. Ah, yes. Okay. I was looking at a different method. Yeah, so it returns SOK. If you recall, I was thinking that that might be the problem. So if we look up the H result, SOK is actually just a value of 0, so this never gets true. So you could say if it's absolutely 0, this succeeds. Yes. Just to be sure that, or rather explicit, we could do it like this. I think that is way, way, way more clear, and shows us that we actually got an OK message back from the method, and once we should return to this part of the code, it'll be clear that this method actually returns an H result. All right. So now we have a temporary interface that we can use, as we saw in our documentation. Let's see, did I have some place where it was easy to look up the factory? Yeah, we had it not here. Oh well. Yeah, here we go. So enum get adapters by GPU preference. That is the method we want to call. We want to check whether our main screen all right, let's just see what it says. So the index are in order of the preference specified in GPU preference, which is the second argument. For example, if DXGI GPU preference high performance is specified, then the highest performing adapter is at index 0. That sounds like something we really would like. So let's do that. We want the, as you might see, this returns an H result. So we will store that enum, and we want the DXGI GPU preference high performance. As you saw from the list, you might choose to do something that has the least power. And let's see, it wants a data structure to store the actual adapter. As you can see, it wants a DXGIAdapter. So we create that. And use the macro to pass in the globally unique identifier and the address of let's see, the address of our com pointer. So yeah, that works. Now we might get different results. Let's see. We can look up the errors. Device hung. The device is well hung, you might say. When calling factory enum adapters or we might get this error message. So we want to handle that. We're going to use a switch for that. So case we have is okay. We will do something and break out this of the switch statement if we have the error, or we would rather have some default action. We handle it like that. So yeah. Let's see. Are there any different error codes that we would like to handle? Access law, blah blah blah. Invalid call, more data, blah blah blah. Doesn't really seem like there are any more relevant relevant error codes. Yeah. So if we find a high performant adapter, we actually found the adapter that we're looking for, so we might as well return it. I just noticed that our naming is both good and bad, since we have an DXGI adapter, but the DirectX naming convention is I for interface. This might give us problems down the road if we get things mixed up, but yeah. It's only a problem for the DXGI. As you can see, the D12 is prefaced by a Direct3D specifier, or rather part of the name. So yeah, it's probably only our DXGI named classes that might end up resulting in some confusion. But yeah, let's then create an adapter with the actual pointer, and thereby we increase the reference count. So even though this one goes out of scope, there will still be a reference to the interface living on in whatever receives this object. So um, like sort other smart pointers, the address of the actual object doesn't get lost during this form of passing around. Yeah, it's somewhat like a shared pointer with reference counting and so forth. So yeah, this should allow us to create an DXGIAdapter by selecting the one that is most performant. And we might want to do something in case this doesn't work. You might want to create something where you just get the primary display adapter. For instance, if the components aren't supportive of the factory 6 interface for some reason, you could just use um, you could just create a few lines of code which passes back the adapter for the main display. Actually, let's do that. So instead of making this as a comment, we would like to say that our our factory here should let's see, factory, does it reside in this part of the documentation? Interfaces, yeah. So we have it right here, our factory, and we will use the enum adapters. Whoops. And as you can see, we just want to store it. Of course, we want the first adapter. And we want to store it in our adapter. So let's see, we will just copy this. And we of course want to evaluate it, since if this fails, we should throw an error, since it means that we won't have an actual adapter. And we do the same thing as before. Let's see. function does not take 3 arguments. Did I do something? Let's see, maybe we just pass in the adapter here. Yeah, so that works. Now we want to create another helper function that allows us to throw an error. If this gets called, we will of course throw an exception, but let's see. We want to pass on a message, and we will throw an exception. So we can use that macro. Let's see, something went wrong. Does it? It's just IntelliSense. All right. DXGIDevice adapter not found. Unknown DXGIAdapter error. Yeah, and it still doesn't throw an exception. I wonder if it's no. Yeah, so as you can see, the total reference count of objects are 2. But what happens if we create a DXGIAdapter and copy in the adapter which we get? As you can see here, the DXGI layer then creates an adapter, and you saw the reference count of our factory increase from 2 to 3. So the adapter gets created from the factory, which then increases the reference count. So now we have an actual adapter at the time we called this function. So everything seems to be working as intended. If we just call this method, how many references will our factory have? It will still have 2. So whenever we construct a factory, even though the factory as you can see here, this method creates a factory, and for some reason the resulting process is 2 reference counts. Probably, yeah, maybe the debug part of the application increases the reference count as well. Probably the DLL of the debug layer gets linked to the factory, so that you're able to report. Let's just test it out. If we decided to change that, would that decrease the reference count? Actually, yeah. So right now, and it's not because we're throwing an error. So yeah, when we create the factory with the debug flag, it gets linked to the debug DLL in the background. It seems, at least. All right. So now we have a factory. Now we have an adapter. We find the actual adapter information. We could say, goddamn IntelliSense. We could say that we wanted to get the pointer. Perhaps there are some interesting functions on the actual adapter interface. Yeah, we could get some outputs. Of sorts, if we wanted that information. Yeah, but I don't think there's any reason to play around with that. So let's do a D3D12 device, and we will look at our implementation. We want a pointer to an adapter when we create this. So remember, since it's a COM pointer, you can always get the underlying pointer by calling get on the COM pointer. So this should be sufficient. Yeah. Let's see. Now we create a ID3D12 device, live device. Yeah. Yeah. So now we have a device. It might not really do anything, but so far we've implemented the different functions that are needed to actually create a device. And now we are at a point where we still could implement our monitor fetching if we need to handle that. We will implement it when needed, but I think the next step that we need to take is to implement a swap chain. And as I've said earlier, I'll be having a break, partly to segment the streams into smaller parts, which are somewhat more digestible than uh, one long stream. Um, yeah, and also to get a short break. Yeah, but I'll probably continue on later today. Um, feel free to look up any previous content on YouTube, or yeah, leave a comment on YouTube, subscribe, or whatever. Yeah, also feel free to comment or leave a chat message if you find any of this content helpful, if you like the series, if you want me to adjust anything, or whatever feedback you might have. Yeah, I think so far we got pretty far today, which is really, really great. Um, I can't really wait till we get into the other parts of this series. Yeah, alright. Doesn't seem like anyone has anything to comment. So I'll just be wrapping it up in a bit. Let's see. Oops. Yeah, I'm just playing around with a bit of the stream. There won't be any more content from now, so I'll just be wrapping this part up. Um, yeah, I'll be checking out. Yeah, I think that is it. Hopefully I'll be seeing you around shortly.